All right. So yeah, as we just discovered, or someone reminded me, thank you, the test needs to happen on Wednesday, lesson 1. Okay? Wednesday, lesson 1 next week, because Monday is public holiday. I totally forgot about that. All right. School. Extra day to study for the test. All right. Now, one last part that I would like to just keep going on. I know it's a lot of lecture component, but after this, you can start doing your revision. All right. So electron shells. Electron shells. It's referring to 5.4 of the textbook. Okay. All right. Come on. All right. So electron shells. You know where electron shells are, yeah? If you look at an atomic structure, nucleus in the middle, and outside there are a few layers of electrons. Now there's a rule to do with that, and by knowing the electron shells, you can actually predict what sort of reactivity or nature those elements have. Okay? Electron shells. Now energy shells where electrons orbit the nucleus. That shouldn't be new, so I might even skip that. Come on. It's a bit slow this morning. Okay. Low energy shells are close to the nucleus. Now, going back to concert analogy, say, I don't know, Ed Sheeran this time. Which one is cheaper for you to buy? Somewhere that's close by, or box seat at the back where you can have food and toilet very nearby? Box is cheaper, you reckon? It depends. But if you don't mind standing at the front and being squashed by other audience, usually the closest seat is cheaper. I don't know, for the concerts that I've been to, like Fat Boy, not Fat Boy, Fall Out Boy and stuff like that, it has been the case for me. What I'm trying to say is the places, so electron shells close to the nucleus requires less energy for electrons to be sitting in. Okay? So electrons don't need to have a lot of energy to be in that. Okay? Imagine a building and say an apartment building, all right? And top floor would probably be one of the en-suites that very expensive to live in. Yeah, but ground floor much cheaper for you to live. All right, so normal people can live in the bottom few floors, and the top floors require more money to live in. All right, so let's write down those rules. So lower shells, which are close to the nucleus, nuclei, requires low energy for electrons to have. Okay? Another thing is that each shell have got different maximum number of electrons. So in a different energy, different shells can hold different number of electrons. And I think we have a table. So for this year, I want you to stick to these numbers. Okay. So main energy shell number 1, 2, 3, 4. In the first shell, you can have 2 electrons. Second shell, 8. Third shell, 8. Fourth shell, 18. 2, 8, 8, 18. You just have to remember those numbers. Okay. Now that's not totally accurate, and it doesn't actually conform the formula that you can use. 2n squared it's called. But 2, 8, 8, 18 makes sense and can explain a lot of things at year 10 level. So we will just go with that. Okay. So main shell number 1, 2, 3, 4, and maximum number of electrons that can fit in important number. So I would like to use red, but I don't have red now. It's broken. 2, 8, 8, 18. Okay. This 8 can be in the center. Just keep using these 2, 8, 8, 18. But if you're continuing on next year, we'll explain why third main shell and fourth main shell says up to 18 and up to 32. Okay. This year, keep using 2, 8, 8, 18.
Is that shell? It looks like an egg.
So main shell, yep. Now, how does it relate to what we are talking about? So low energy to high energy is already mentioned. We'll go rid of that. Still writing the table. So 2, 8, 8, 18. Let's do a bit of example. All right. First example, let's take our favorite element that makes up our body, carbon. Now, think of the number of protons in carbon, please. How many protons are there in carbon? It is a 6, yeah, because atomic number of carbon is 6, yeah? How many electrons are there then? This is going to be in the test. That's why I'm giving you this revision time. Carbon is element number 6, yeah? How many protons are there? 6, that's positive. How many electrons are there? 6. Positive and negative are the same in the element. Okay? All right. So 6 electrons should be there. Right. We just said there are different levels of energy shell. Okay? How do we draw or divide the 6 into different shell? How many electrons out of that 6 can go into first shell? 2. Okay. How many are left then? 4. Okay. So the 4 electrons, leftover ones, have to go into the next shell, second shell. So there will be 2, 4 electrons. Okay. And that's how you draw electron configuration. So in the diagram, you would see 2 electrons in the center, in the first shell, and leftover 4 in the outer shell. All right? Are we getting the hang of it? Shall we do maybe sodium? I'll do the drawing here. So carbon, for example, carbon has 6, yeah? There's a dot representing a nucleus, and we said 2 are in the inner shell, in the outer shell, there are 4 electrons. And in total, there are 6 electrons. Yeah? Now, this is how you draw. Okay? Drawing of electron configuration. If you're asked to write that, you just say 2, 4. Okay? So that's drawing and writing. Let's draw and write the electron configurations for sodium. What's the number of proton? 11. So how many electrons are there in sodium? 11. Same number as the proton. Okay with that? We've covered this before. Okay. So 11 electrons are there. Okay. All right, think about it. How many electrons out of these 11 can go into first shell? 2 only. You always fill the inside shells first. So 2 in the first shell. And next. 10, I heard that. And are you all agreeing? 10 is good? Sorry, not 10. 10 is a leftover. 10 is a leftover. Look at the maximum number of electrons which second shell can hold. 8. If there are 10 electrons, 8 out of the 10 will go into there. Sorry. So 11 electrons, you'd have to take 2 out first, right? And then next 8 is going to be used up. What's the leftover? 1 leftover, which can go into outer shell. Okay? So as necessary, you keep putting the shells. Okay? 2, 8, and you will have 1 electron. Yep, until all of them can fit into. Okay? Sorry?
Oh, wait, so every single time you have the element or whatever, the shell always has 2.
Yep, always can have up to 2. The hydrogen, there's only 1 electron. Yeah, so you don't have to fill 2. That's right, 1 dot is only necessary. Just like sodium, having 1 extra one in out shell. Yeah. And if you used up 2 rooms that's available for the first floor and 8 in the next floor, then you just add. Electrons have no choice to climb up the stairs and live in that next level. Okay. Just as a note, guys, saying that this is drawing. Yeah. And these are writing of electron configuration. Okay? Okay. Now I'm going to get the worksheet for you so you can complete that. And this worksheet, I would like you to glue it onto over 2 pages. Okay?